So hello students, welcome to my second class on tricks on rotational mechanics. So here I am going to discuss calculation on moment of inertia. Lot of many questions come in JEE main based on this subtopic. So moment of inertia is actually summation of r squared dm, or if you have a rigid body like this, so moment of inertia about the axis of rotation. So there you have, this is the axis of rotation. So if you have a small mass dm located at a distance r from the axis, then you get I is equal to integral r squared dm, or it's actually summation of r squared dm. Summation is the integration, as you know. So moment of inertia abbreviated as I, or MOI in short. MOI depends on the radial distribution of mass, it doesn't depend on the axial distribution of mass. ये देखो, ये सब जानने से ना many problems you can solve without integration. ये देखो, moment of inertia of a particle, ये देखो, a point mass है. Now first we will start with a point mass at a distance, yeah, that is the axis, at a point mass m at a distance r. So for that you get I is equal to mr square. Quite simple, you know. Now if you stretch the point mass axially without changing the radial spread of mass, if you stretch the point mass axially parallel to the axis, so you can make it into a rod, whatever the length of the rod may be. So still, you know, I is equal to mr square, because here the radial distribution of mass does not change. यहाँ पे radial distribution of mass change नहीं हुआ. क्या change हुआ? Axial distribution of mass. So parallel to the axis you can stretch or compress, whatever you can do, I will not change. So same way for a ring also, you know, from the axis all points, I mean see for the ring, ये देखो यहाँ पे axis है, I am showing the top view. So all the particles are equidistant from the axis. So for the ring also you have mr square, even for the hollow cylinder you have mr square. Once you know it for the ring, you know it for the hollow cylinder as well, because a ring, if you stretch the ring axially, it will become a hollow cylinder. Now same thing, if you have a sector, I mean not really a sector, an arc rather, if you have an arc like this, regardless of the angle subtended by the arc at the center of curvature. Now center of curvature of the arc, here is the axis, and the axis is perpendicular to the plane. So here it is theta. So suppose the mass is m and the radius r, so what will be I for the arc? You know, it is equidistant. Now every point on the arc is equidistant, so it is actually mr square. Every point on the arc is equidistant from the axis of rotation. Okay, so next page देखो, disc का क्या होता है? We all know it is half mr square, and solid cylinder also you get half mr square. इसका reason क्या है? You know, the reason is very simple. From a disc, if you stretch the disc axially, you get a hollow cylinder, and even the same for a sector of a circle, a sector of a disc. Okay, for a sector of a disc, here see the axis is perpendicular to the sector and passing through its center of curvature. Here the radius of curvature is r, and the mass of this portion of the disc is m, sorry. So here also you get half m r square, because the radial distribution of mass, ये देखो यहाँ पे जो रेडियल डिस्ट्रीब्यूशन होता है ना, सो यहाँ पे जो रेडियल डिस्ट्रीब्यूशन है फॉर द डिस्क एंड फॉर द सेक्टर, इट इज एक्चुअली सेम. अच्छा ये देखो, ये है रॉड का, you know, for the rod it is ml square by 12, and for the rectangular plate also it is ml square by 12 by the same logic, you know. And for the, what happens for a rod about the end, for the rod about the end, if the length is L and the mass is m, so about the end it is ml square by 3, it is perpendicular to the length of the rod. अब देखो ये rod ना होके ये अगर ऐसा होता, a rectangular plate, so axis is about the end, okay, and along one side, see, and suppose this length is L and suppose this length is h, but you know I about this axis happens to be ml square by 3. It is not dependent on h, because h is along the axial direction. Okay, now next, for a hollow sphere, you know, I is equal to how much? hollow sphere में कितना होता है? 2/3 mr square. अब देखो hollow hemisphere में कितना होता है? अरे भाई hollow hemisphere में तो सेम ही होगा. hollow sphere का जो होगा hollow hemisphere में ही सेम होगा, क्योंकि the radial distribution of mass is same. ये देखो इसका रेडियस आर है, मास सेम है, एंड इसका भी मास सेम है, रेडियस आर है. गलती से क्या करते हैं लोग, मिस्टेकनली पीपल डू दैट, ये हॉलोस्फीयर का तो 2/3 m² हो गया, इसका 2/6 m² होगा, मेक इट हाफ. बट सी इट्स द हॉलो हेमिस्फीयर, द हेमिस्फीयर इज हैविंग मास m, not m/2, so that will be same. I is equal to 2/3 mr². Now solid sphere, you know, it is 2/5 mr², and solid hemisphere it will be same, 2/5 mr², provided the mass is same and the radius is also same. Come on, let's go to the next page. Now perpendicular axis theorem, you know, it is valid for laminar or plane bodies. So suppose there is a body in the xy plane, ये देखो body जो है xy plane में है, इसका thickness negligible है, very small thickness t, almost negligible, it's almost a plane body, and the body is along the xy plane. So Iz equal to Ix plus Iy. Iz is about the z axis, moment of inertia about the z axis, Ix is about x axis, Iy about y axis. Parallel axis theorem, you know, so I equal to Icm plus md square. So what is Icm? Say consider any centroidal axis, mean any axis passing through the center of mass, that is the centroidal axis, and there is one more axis parallel to this centroidal axis and at a distance d from it. So you have this I equal to Icm plus md square, right? देखो यहाँ पे एक गलती करता है लोग, ये एक गलती करता है, आई विल टेल यू. ये देखो ये डिस्क हो गया ना, ये डिस्क हो गया. So about the centroidal axis, what is ICM for the disk? So about the centroidal axis, it is mr²/2. Now if you choose this axis, so what will be it? Distance तो r हो गया, so here equal to ICM plus md square, that is mr². So that's valid. But लोग क्या करते हैं ना, कोई भी एक बॉडी है, कोई भी दो पैरेलल एक्सिस है, उसका बीच में अप्लाई कर दिया, तो ऐसा तो नहीं चलेगा ना. If you have any two axes, you cannot apply parallel axis theorem for any two parallel axes. Remember that. It is valid for, it is I equal to ICM plus md square, and I about the center of mass, or I about an axis through center of mass is the least. अच्छा, अब देखो, let us take up a problem that has been asked in JEE Main 2019. An equilateral triangle ABC is cut from a thin solid sheet of wood. D, E and F are midpoints of the sides. The moment of inertia of the triangle about the axis passing through G perpendicular to the, if the small triangle is removed, moment of inertia of the remaining figure of the axis is I. सो टोटल का I0 है. ये देखो यहाँ पे एक ट्रिक अप्लाई करता है ना, नो इंटीग्रेशन, नो हेक्टिक कैलकुलेशन, ये सब कुछ नहीं है. मोमेंट ऑफ इनर्शिया एक्चुअली, यू नो, I is proportional to mass into some characteristic dimension square. So for this equilateral triangle we will take this length, so I is proportional to ml square. अब देखो यहाँ पे जो कांस्टेंट होगा, so I is actually k into ml square है ना, if L is the side of the triangle. Now so this k, suppose you don't know k, but whatever, it will be something na, 2/3, 1/3, 2/9, 100/37, whatever it may be, k is a constant and it's a constant for this equilateral triangle. So अब देखो ये काम करते हैं, ये जो equilateral triangle, if you have this total equilateral triangle, यहाँ पे total equilateral triangle है, इसका एक देखते हैं, और यहाँ पे जो छोटा वाला इक्विलैटरल ट्रायंगल है इसका देखते हैं, ये छोटा वाला इक्विलैटरल ट्रायंगल का देखते हैं. नाउ इसका साइड क्या हुआ, L, इसका साइड क्या हुआ, इट इज़ L/2. अच्छा, सो ये देखो, फॉर दिस इक्विलैटरल ट्रायंगल द मास इज प्रोपोर्शनल टू द एरिया, सो मास इज प्रोपोर्शनल टू L² बिकॉज द थिकनेस इज इट्स सेम थ्रू आउट ना. So the thickness of this equilateral triangular sheet, that is same throughout. So you have this, so m proportional to, so ultimately I is equal to k into L to the power 4. So इसका moment of inertia I0 equal to k इंटू एल टू द पावर 4 एंड इसका जो होगा ये देखो रिमेनिंग पोर्शन है ना, सो सपोज दिस इज आई डैश और आई प्राइम, so I prime is equal to k into L by 2 to the power 4, so it is L to the power 4 by 2 to the power 4 मतलब क्या हुआ 16. okay, so now moment of inertia और क्या दिया है I, remaining portion I, you know I by superposition, you know I equal to I naught minus I dash, so I is equal to k L to the power 4 minus k L to the power 4 by 16, that is 15 by 16 k L to the power 4. So from here you get I is equal to 15 by 16 times I naught. So I think you have got an option here. I is equal to 15 by 16 times I naught. Let us take one or two more problems. Let us take this problem. ये देखो, moment of inertia of a solid sphere about an axis parallel to its diameter and moment of inertia of a क्या दिया है ये sphere. अच्छा, moment of inertia of a solid sphere about an axis parallel to its diameter and at a distance x from it. So it is not given whether the axis is outside or inside, whatever. So this is the centroidal axis and this is one more axis at a distance x. This is the axis through center of mass, that is the centroidal axis. तो अब क्या होगा, which of the graph represent ix versus x properly? You know I equal to ICM plus m times x square. So ICM, so I जो है ना, so x equal to 0, then I is minimum. So x equal to 0, I is minimum and rest of the curve, you know, it is proportional to x square. ये देखो I equal to ICM plus m times x square. So surely it will be like this. ठीक है, चलो, stay tuned for the next video. Best of luck.